Quick revision video on redox. So we'll start with the essentials. Redox reaction is a chemical reaction which involves both reduction and oxidation processes. Oxidation and reduction can be defined in terms of electrons or oxidation number. So in terms of electrons, we use the oil rig acronym. So oxidation is loss of electrons, reduction is gain of electrons. And in terms of oxidation number, oxidation is the increase of oxidation number, reduction is the decrease of oxidation number. And in redox reactions, the change in oxidation number for the oxidized species is always equal to the change in oxidation number for the reduced species. So you'll see that in action in the examples I've chosen. So first example, we've got this redox reaction between aluminium and hydrochloric acid. So if you want to pause the video and establish the oxidation and reduction processes, both in terms of oxidation number first and then electrons second. So starting with oxidation number, well, the first thing I'm going to do is put all the oxidation numbers above all of the species in the redox reaction, and you can see now that we've got a change in oxidation number for the aluminium and for the hydrogen. So in terms of oxidation number, the oxidation number of each aluminium has increased from 0 to +3. So aluminium's been oxidized, and the total increase in oxidation number is 6 because we've got 2 moles of aluminium and each one has changed by 3. So moving on to the reduction process, the hydrogen oxidation number has decreased from +1 to 0. So hydrogen's been reduced, and the total decrease in oxidation number is 6, and that matches the increase of 6, and that's because we've got 6 moles of hydrogen in 6 HCl's, so each of these +1s has decreased down to 0. There's 6 zeros there because we've got 3 moles of H2. So in terms of electrons now, the 2 moles of aluminium, each of those has changed into an Al3+ ion. So they've done that by each one losing 3 electrons. So we've got this half equation here to explain that. The bottom line there is the aluminium has lost electrons, so it's oxidation. Now on to the hydrogen. So those 6 moles of H+, each one's gained an electron and formed, well, technically formed 6 hydrogen atoms, and they've paired up to form 3 moles of H2 molecules. So here's another one you can try. So same again, we'll do oxidation number first and then we'll do it in terms of electrons second. So there's all the oxidation states in there. So we can see that the manganese has changed its oxidation state, and this time the chlorine has. So the oxidation process, so 2 of those chlorines, you notice there's 4 chlorines here in 4 moles of HCl, each one's at -1. 2 of them have changed, have gone up to 0. You can see these 2 haven't changed. So the oxidation number of 2 of the chlorines has increased from -1 up to 0. So we can say that the chlorine is oxidized or partly oxidized. Total increase in oxidation number is 2. So the reduction process now, the oxidation number of the manganese has decreased from +4 to +2. Manganese is therefore reduced, and the total decrease in oxidation number is 2. So that matches with the increase of 2 for those 2 chlorines. In terms of electrons, so those 2 chloride ions, or 2 of the Cl minuses from the 4 HCl's, they've each lost an electron, formed a chlorine atom, and then they've combined to form the diatomic Cl2 molecule, and the Mn4+ ion in MnO2 gain 2 electrons and become an Mn2+ ion. We'll take a look at disproportionation reactions now. So these are special types of redox reactions where the same substance is oxidized and reduced. The example I'm going to use is the reaction between chlorine and water. So again, if you want to just pause the video and show what's been oxidized and what's been reduced in that reaction. So there's all the oxidation numbers in. You can see chlorine has gone from 0 to -1 and from 0 to +1. So that's why this is disproportionation. So 1 chlorine has been oxidized and 1 chlorine has been reduced. So we'll finish with oxidizing and reducing agents. So starting with oxidizing agents, they cause the oxidation of another species. In other words, they'll cause the other species to lose electrons. So they themselves will accept electrons and be reduced in the process. Reducing agents, they cause the reduction of another species. So they cause the other species to gain electrons. So the reducing agent must provide the electrons. So these are electron donors. And therefore reducing agents get oxidized in the process. Because they're giving away electrons, they are therefore losing them. So we'll put that into practice with this redox reaction here. All we're going to do is identify the oxidizing and reducing agents. So for the last time, if you want to pause the video, have a go and then play on when you're ready. First thing I'm going to do is put all the oxidation numbers in. So you can see from those numbers the tungsten oxidation number has gone down. It's reduced from +6 down to 0. So W6 plus in the WO3 is the oxidizing agent. So what is it doing? It's accepting 6 electrons from the species that's been oxidized, and it's been reduced in the process to tungsten, W the atom. So moving on to the reducing agent, hydrogen has been oxidized from 0 to +1. So hydrogen is the reducing agent, and what's happened is those 3 moles of H2, so each of the hydrogen atoms in these 3 moles of H2, they've each lost an electron and become H plus ions. And obviously those 6 electrons are the ones that's being given to the W6 plus to become tungsten the atom.